Good afternoon to all of you. Last class we discussed some uh, examples of manual control system and automatic control system. What are the components in automatic control system? So 1 minute, 1 minute. The next manual control system we discussed about the hot water that is a temperature control of spray uh, used for bathing. And also we discussed automobile vehicle for speed, that is for getting desired speed by the driver. So and then we also discussed about that water level control in the tank. It is automatic control system example, that is. And also we discussed about the automatic robot building. So these are the things we discussed yesterday's class. Now we are going to discussing about that feedback characteristics and examples on automatic control systems. Here already we discussed so many examples. I already yesterday I asked you that anyone come with examples of automatic control systems, some examples which are there in the our household appliances. One person has written one yesterday. He dropped one message regarding one application. So who is that person? You can talk. I will unmute you. So anybody, can you come with one example? Anybody, can you come with one example of automatic control system? So anybody. Yesterday I already told to you that come with example. Fast. Don't waste the time. Washing machine, right? So I will unmute you, Mr. 313. You just to go, briefly explain what are the parameters. 313, Danukoti, your name is Danukoti, right? Uh, right.
Good afternoon, sir.
Good afternoon.
సార్ వాషింగ్ మెషిన్ మనం కంట్రోల్ ఇస్తే అది ఆటోమేటిక్గా అడ్జస్ట్ చేసుకుంటుంది కదా సార్.
Okay. So here, which parameters is to be under control in washing machine?
నో ఐడియా సార్.
Amma? In your house, washing machine is there?
నో సార్.
No, here speed, valve, here drum speed, right? And the valve to control the water into the drum or cut off the water. And also the another one more parameter is there, that is three modes we are giving input, maybe the slow rinsing speed, medium rinsing speed, and fast rinsing speed. So according to that we can get the output within the duration of the time. So all that dirty clothes will wash. And then if you need any drying option means, then you can give the input parameter, so that all the inputs we can get whatever you can give the input, we can get the same as that of the output as the reference input. So anybody with some examples? Examples చెప్పాలి, రావాలి. Yesterday I already given to you this task. Anybody? చెప్పాలి. In our household appliances, iron box is there. Automatically, the temperature is controlling. If the temperature reached to that particular desired temperature, then automatically it is in off condition. Whenever it decreases to the desired temperature, then automatically the iron box on. It is in on condition. That means automatically the iron box on and off. That is it is controlling the parameter temperature. So anybody like that? Refrigerator. So number 330, right? Unmute చేస్తున్నాను. We can talk. 330. 330 unmute కమ్మా. 330. Okay. Next, any other? Any other? Any other? Correct. Will anybody? Anybody? So there are so many are there. See here, even in our household appliances, what he said, the refrigerator. So in the deep fridge also we can control the temperature. And nowadays the smart refrigerators are coming. So the display device is there monitoring. With the help of that we can control the temperature inside, so that the foodstuffs will be that means the foodstuffs whatever we stored in refrigerator should be safe. And then AC, about one person said that AC 317 lateral entry. I will unmute you. You can explain it. 317. AC correct.
Sir, good afternoon, sir.
Good afternoon, Krishna. Good afternoon. Speak about here. What is the parameter controlling?
Sir, temperature, sir.
Right. Very good. So it is an automatic control system.
Manual, sir.
Manual means
అంటే అదే టెంపరేచర్ అనేది మన రిమోట్ ద్వారా టెంపరేచర్ కంట్రోల్ చేస్తాం.
that means you are giving input to the AC.
Yes, sir.
Then the output is the same temperature. That is automatically controlling, right? If the output is not our desired output, then we can control by manually. But whatever you are giving input, for example, you are setting 20 degrees centigrade, you are getting the output is also 20 degrees centigrade without any manual adjustment.
Yes, sir. Yes, sir.
Are you getting?
Yes, sir.
Right. So it is an automatic control system. Here the temperature, whatever you set at a given input, that is the output without any involvement of a human. It is automatically controlling. So already last class we discussed some of the systems, control systems we are controlling with manually, like a fan with a regulator, right? Fan with a regulator, right? With the help of the regulator you can control the speed of the fan in different modes. Whereas in the case of what we discussed, another one, temperature of a shower bath, it may we need whatever the temperature we need the water, we can control manually with the help of the hand. That means you are getting the desired output by setting manually. So but here in this AC, in the input you are giving the output, whatever you given input, that is we are getting the output without any manual. So right?
Yes, sir.
Right. Any other examples? Okay, mute them. Any other examples? lock system in water tank, right? Correct. So water level in a lock system means 326. Lock system means
గుడ్ ఆఫ్టర్నూన్ సార్.
good afternoon.
అంటే ఓవర్ఫ్లో అవ్వకుండా వాటర్ ట్యాంక్ లో మనకి లాక్ సిస్టమ్ అనేది ఉంటుంది సార్ ఇది.
Right, right. So that we can get the beep sound, right? Or otherwise automatically it will lock.
ఎస్ సార్.
Lock
Yes,
means the power supply is in off condition, right?
ఎస్ సార్.
Okay, okay. Any other? Anybody? Anybody? Any other examples? Automatic control system. Oven. In our household appliances, oven is there. And bread toaster is there. And even geyser, right? CNC, right? A computer numerical control, right? Very good. So here the operations are performing a sequence manner, and also the tool post is automatically adjusting. So whatever the tool we have to perform on that particular job with some particular operation, then the tool automatically will change. Geyser also we can control the temperature automatically, right? Very good. Any other examples? See here, even in a rice cooker also automatically, whenever the rice completed cooked, automatically should be maybe the red color light is there and some yellow color light is there. Automatically the yellow color will on. If the food is complete, whatever the rice is, it is cooked completed, the light goes. Both process motion control can be automatic and by a program, right? Automatically controlled by a part programming, which we have to feed it to the CNC machine. We can control the motion control, right? We can control the motion as well as here you are saying that both process, that is a sequence of operations. That sequence of the operations is depending on the given program, whatever you are written part programming with the help of some software, and then we have to feed to the CNC machine. Then the operations are going on smoothly by uniformly, right? So here the motion control automatically controlled by CNC. And driving system in electrical vehicle, right? So that means what? Number 338. So 338 driving system in electrical vehicle means autopilot. Very good, very good, very good. Autopilot 312, Raviteja, very good. One person said the driving system in electrical vehicles. That means here the speed is maintaining constant. Speed of the vehicle is maintaining constant. GPS location, of course, maybe, right? Very good. GPS location. So automatically you can go for the GPS location, right? Any other examples? VPN. What is VPN? So Raviteja, I will unmute you. 312 Raviteja. Raviteja, unmute. VPN means? Unmute come. Assembly of automobile in industry by robot, right? Very good. It's here completely some in robotics. Here some process is going on with the help of the human, but nowadays it should not be like that. For example, car having so many components, all the components are assembled by the robot automatically. So when it is comes to one particular station, then automatically some of the components will be assembled, and then it goes to the another station. Then again there some of the components may be fitting section. So this should be automatic. That means human is completely replaced by that automatic systems. Okay, no problem.
అది విపిఎన్ virtual private networks ఆటోమేటిక్ గా జిపిఎస్ లొకేషన్ చేంజ్ చేసుకోవడానికి యూజ్ అవుతుంది.
Oh no, no, okay.
దానికోసం చెప్పాను.
Okay. The next one person said that car frame assembly automatic, right? Very good. Car frame, right? Car, that means frame assembly. So these are all automatically controlling without any human involvement. We are getting the desired output with accurate. So now, today we will discuss about the feedback characteristics and examples of ACS, means automatic control systems. Already we discussed several examples now. Let we will go for feedback characteristics. Feedback characteristics. Already yesterday I discussed some of the components in automatic control system of feedback element. Right, feedback element is nothing but whatever the signal, the output we are getting from a system, the output is not the desired output, then it goes to the feedback. So in that, what are the feedback characteristics, we will discuss one by one. So almost all whatever we discussed in the previous, same briefly I am going again. So somewhat in depth we are discussing in the feedback. So here what are the basic elements of a feedback system? Here, if you observe clearly, here the forward path, feedback path, and error detecting device. In this forward path, there are error sensor, amplifier, and compensating it. That means forward path means here this is a system. From this here we are getting the output, and this is input, the error detector. So this here the controller is there, right? And then it is a system. It is a system. It is a system. So here from here to here, this one we can call it as a forward path. From this one forward path to the system. That means here we are getting the feedback signal from the output to the, again it goes to the input. This is the reference input. This is error detector, right? And then from here onwards, it moves towards the system, whatever the process, that is called a forward path. We can call it as a forward path. And feedback path, this from the output, whatever the feedback we are giving to the input, we can call it as a feedback path. So these are the two, forward path and feedback path. And error detecting device, you know very well, that is error detector. It is detecting the how much error is there, right? And the next is here in this forward path, what are the here error sensor, amplifier, and compensating networks. These three are there. If you observe clearly in the error sensor means it errors, it finds this is the error sensor. It finds the error, that is the output value to the reference input value. So if these two values, difference of these two values, some value is there, means then some error is there. With the help of the error sensor, we can find out the error. That means whatever here automatic control system means, whatever you set that reference input, that should be the same or reflected in the output, same. So that is the desired output. Whatever the we are setting as the input as the reference. So if the difference is there means, then automatically the error, the error sensor finds out the error. And then amplifier here we are arranging in the controller. Here in this amplifier as well as controller is there. So the help of the amplifier, it amplifies the error signal, which is transmitting from the error detector, which is whatever the error received by the amplifier. And then here the amplifier The function of the amplifier means it amplifies the error. The error means here the signal is in weak condition. So this amplifier makes the signal strengthen. And some compensating networks here we have to arrange in this here. Compensating network means some of the element is working in such a way that compensating with other, so that we can get the output accurate. Maybe the filters, we can arrange the filters, some signal conditioning components we can also arrange. That means signal conditioning elements. So that is the basic elements of the feedback. And then next in this error sensor, what I discussed with you, it receives the output signal and compare with the reference value. Reference value is reference input. Here we are giving the reference input value, that is output value and reference input value. That is the difference of these two. And it can generate a command, or that is nothing but the error signal. If it is there is no difference, means then the output is the that is whatever the that is the output value is reached. And the compensating system, in this compensating system, here see, if you observe, it is required in forward and backward pass to improve the overall performance of the system. Here what I said to you, you have to add some of the electronic components to get the that means performance of the overall system may be increase or improve with the help of this compensating system, which is arranged maybe in the forward path or maybe in the backward path. That means at the feedback element we can also add this some elements. Maybe in the forward also we can add these elements. And then here classification of the feedback control system. Here in this, if you observe, regulator system, follow-up system, servo mechanisms, continuous data system, sampled and discrete. It's completely somewhat electronics words are there, so no need to worry. So here these whatever all the classification should be very simple. So regulator, I think all of you know that a regulator system, right? Follow-up, servo mechanism, I will discuss this one, and continuous data system, sampled or discrete data systems. So these are the classification in the feedback control system. See here one. If you observe clearly in this here in the regulator system, see here in the regulator system, a feedback system where input is not changed frequently. Here in this regulator system, here input we cannot change it frequently. Cannot change it frequently. Once if we give the input, then we can get the output. So here we cannot change the input frequently. That is the regulator. So here, for example, a fan is operating with the help of the regulator means once if you set it to mode, then you can get the output. So here the input is not changed frequently, cannot change it. So once if you set, for example, second mode or fifth mode, then you are keeping on as it is till the overnight or maybe some days together. So like that, that means we cannot change it. We cannot change it. Here input we cannot change frequently. So example, home heating or cooling system. Example, home heating. Once if you set the input, then that should be the same. Even though if it is not our desired output, and automatically, once if you set means it should be like that only. Otherwise, maybe we can change the input maybe some more days. And follow-up systems, I hope so you understand, right? Follow-up systems means, see here, the input changes at every instant of time. So here the input we can change at every time. And hence the output also, which is, see here, if you observe clearly, the output should closely follow the input. That means, here the output follow whatever you given the input. Here, this is the follow-up systems. That means, for example, take the AC. First, you set at the 20 degrees centigrade. Total complete room is very chilled. Then again, you are setting the input. That means you are increasing the temperature. Maybe you are setting 25 degree or 26 degree temperature in the room. Then automatically, that means you are setting the input frequently. You are setting, see here, input changes at every instant of time. The input may be changes, flexible according to our required input. So the output follows the input, same as that of the input you given. See here, if you example space crafts and a tracer mechanism on lead, tracer mechanism on lead. So these are the examples. And in the servo mechanisms, if you go for servo mechanisms, the feedback control system with the mechanical quantity as the final output. Here, in this feedback control system, once if you give the feedback, here mechanical quantity, mechanical variable, it should be the final output. That servo mechanism. Here, for example, if you see in the ATM machine, here when you giving the input to 2000 or 3000 rupees, you need whatever the money, then automatically inside some mechanism is there. So with the help of that mechanism only, that means you are getting the money output. So it is highly impossible. Some mechanical mechanism is there inside, mechanical arrangements. So for example, 500 rupees, for example, you type 3000 rupees. It will give 500 rupees, five number, and 100 rupees in 5 in number. So here, see here, if you observe clearly, what is the mechanism incorporated inside ATM? That is that mechanical mechanism, that is nothing but we can get the final output correctly. Final output. Even if you see some mechanisms, see for example, take the engine, the piston which is moving inside the cylinder. It is go for that means 4-bar link mechanism it is. So here the piston is moving to and fro motions. That means a straight line motion mechanism. So here with the help of the mechanical mechanism, we can get the output linear motion. So here that the arrangement should be mechanical in such a way, right? Here it is an automatic device used to correct the performance of a mechanism by means of error sensing feedback. With the help of the error sensing feedback, here the performance of the mechanism should be making it correct. So whatever the error from the feedback, so with the help of these mechanical arrangements or some mechanical mechanism, the performance of that system will increase. That is it's making correct means it is improving. And here, if you observe here, feedback and error correction. So that means this mechanical arrangements, that is some mechanism, servo mechanism, so making correct the output, thereby the performance of that system will improve. And it also controls the mechanical position. What I said to you that in the single acting cylinder, that is a linear motion. So mechanical positions. That means, for example, lever arrangement, pivot lever arrangement, and some, for example, knuckle joint. If you observe, that is applications. That means we can go for moving a robot arm to, or see here, here my hand is there, right? I will move it linear, and also I will rotate. See here, this is see here, it is rotating. See here the joint. This is completely a mechanical arrangement. Example, I am mechanical arrangement. So some of the robots may be 3 degrees of freedom or 2 degrees of freedom. That means maybe one linear motion, one rotation, and again the linear motion, maybe some reciprocating motion like that. And these servo mechanisms consists of 3 parts: components, controlled device, output sensor, and feedback systems. In this servo mechanism, the examples: movement of load over certain distance, rotation of shaft through the certain angle. What I said to you, that rotation and linear both here is servo mechanism. Same what I said example, right? So moving of load here, I am carrying a cell phone, right? It's moving from one place to the another place. So maybe it is in some, it will travel some distance linear, and maybe rotation, and then it is placing at wherever required. So that is like that. It's a pick and place, right? In that pick and place motion, here the motion will be controlled with some mechanical linkages, as well as the motion, maybe the rotation or maybe the linear. That means this angle, a certain angle, it will rotate with certain angle. Okay. Next, we'll go, what are the requirements of the control system? What is the time now? Okay, right. So I will, within 5 minutes, we will discuss. And requirements of control system. So here the stability and accuracy, speed of response. Accuracy means if you go accuracy means the error is 0. You can get the output is the desired value. It is the true value. Whatever you set the input, same as that of the output. So the error is 0. And stability means sometimes some after fluctuations, we cannot get the correct value. So the fluctuations, for example, if you run an engine or some other equipment, so some fluctuations takes place. We cannot able to read the reading. The reading will be fluctuating. So after some time, the stable conditions, then the needle, whatever the pointer will be in steady state. Then we can take the reading. So that is actually, that means in this control system, stability, that means after fluctuation and variations, some oscillations or some vibrations. So after the some disturbance will occur. So we need to take the output, the desired value, whenever it is unstable by some particular time. That means stability means some due to disturbances, maybe it will not stable. If you can take that, it's here after fluctuations, variations, oscillations or vibrations. Speed of response. Here the time taken for the respond to give for a given input, the output should be the speed. So whatever you given the input to any system, the output should be respond very fast. For example, if you on the switch, if the TV is on automatically, then the response of that particular system should be good. For example, even though if you on that, for example, maybe the TV after some 1 minute or 2 minutes, it will respond, then the speed of response is very good. So in the, especially in this control systems, the speed should be more. Speed is more. Whenever you give an input, the time taken to get the output is less. So that it is, you can call it, it's an accurate. And example, one example, we will discuss one example. So here see electric furnace. This is a heating coil. Right here with the help of the AC supply, this furnace is heating with the help of this coil. And so the sensor, here the sensor, what is the function of the sensor? It detects the variable from this electric furnace environment, and then it sends the analog signal to ADC. And here ADC means it converts the analog signal into the digital signal, and then interfacing takes place, and then lastly we can get the display unit, how much temperature in the furnace, right? How much temperature in the furnace, right? This is see, actually this process is not altered automatically. That means it is an open system. Actually, we are getting the output whatever the temperature in the electric furnace. Here, see, again, I'm repeating. See here, here the electric furnace is there. With the help of this heating coil, the temperature is supplied in the furnace. So here the AC supply is there, and then the coil gets heated and the temperature increases in the electric furnace. And the sensor, it detects that variable, the temperature from the electric furnace, and then it sends signal to the, it is converting that electrical signal, that is, which is in the analog form, is converting into the digital form. There, here the interfacing takes place, and then we can get the display, the temperature, how much temperature is there inside the electrical furnace. But it is not automatically controlling that parameter. So this is an open system. And we'll go for the next one. See here, if you observe, this is a closed loop system automatically. Same example. Same example. If you observe, see here in this, if you observe clearly, electric furnace, and with the help of the AC supply, this is coil. Coil gets heated and the temperature is increases in the furnace. And the same sensor, ADC, and interface circuit, and computer microprocessor. And here whatever the output, if it is not the reference input, we have to give, we have to set the reference input at here. Then automatically some error is there, means it will convert again that digital, whatever the displayed in that device digital, that digital again it is controlling, that is converting into analog form. And here the signal that is making correct. The amplifier is making the signal correct, whatever you set at the reference input, whatever you need the desired output temperature. Then again, here the AC supply relay circuit, it controls, it's nothing but a regulator. It controls the supply of current, thereby the coil maybe that gets heated more, or maybe the heating will be less. So according to that, we can set the temperature in the electrical furnace. So here it is mainly depending upon the coil heating, or maybe the depending upon the coil heating, right? That is, we are here with the help of some automatic relay circuit, we can control the heating of the coil in the electric furnace. That means with the help of the regulator, we can adjust the supply voltage so that the temperature in the electric furnace is accurate. So now you got the right, you got it, right? You got it? You got it, right? You got it? So any examples? Any examples? Correct. So that is the examples. So any other? Right? Okay, okay. So now the time is 1 o'clock. Almost all members are very hungry. So you can take lunch, right? So anything any examples like to share? Anybody can share? But if we discuss one example, what application of this circuit? Here, see, application here in industries to control the temperature in the electric furnace. So, for example, in some electrical furnace, maybe the temperature is very high to heat some metals. Maybe 1500 degrees centigrade, that means from solid state to molten state. If you go for Vizag steel plant, there are so many furnaces out there. These furnaces are heated with the help of some heating coils. Here, that heating coils, the heating source will be adjusted with the help of the regulator for current, supply of current. So these arrangements actually is mingled with this electronic components. Sunil, okay? Here automatic control system means actually here system is nothing but a mechanical system, but controlling all the things by the electronic and electrical. So no need to go for depth. If you go for depth in that components, somewhat you disturb it. So no need to that. So here you can go for learning of a mechatronics. Now it is you are in the at least that means you are in the second year. If you go for third year and final year, so depending upon the variation in the courses, then you can understand much more. For example, in the fourth semester of mechatronics is there in elective, or MEMS is there in elective. In the mechatronics, you can get all the things. In which way the system will activate with the help of some electronic device. That means, for example, amplifier, filter, attenuators, or maybe some A to D converter, D to A converter. There in the mechatronics course, all the things are there. So that means it is totally. So why you have to go for this the disciplines? That means electrical and electronics to get the accurate value. See, the first mechanical system, we cannot get the desired output. To get the accurate value or optimized value or the finest value With this mechanical system, we have to mingled with some flavors of disciplines like electrical and electronics, or maybe some computer-based information system. So we can get the value output very accurate, and it may be the automatically controlled, right? Servo motor, right? Examples. In the next unit, we'll discuss about the servo motors, right? Servo DC motor and servo AC motor. Okay, here the unit ends. Thank you to all of you. So now take your lunch.